There we go.
Hey everyone, how are you doing?
And I think we have a topic.
Liran today is going to talk about Node.js security, and I think we cannot wait to see his presentation. So Liran, I'll just bring to the stage your slides, and there we go. Yes.
All right, cool. So also, if you have any questions during the whole thing, please add them in the chat, and we will be happy to moderate them. And like we'll have this as an interactive session where people can just like ask questions, and we can walk through this together. So welcome to Stranger Danger. Your JavaScript attack surface just got bigger, basically. Let's see why. My name is Runtime. I'm a developer advocate at Snake. I enjoy working with developers, doing education, doing a ton of stuff with the community, the Node Foundation, open source, SOAS, all of those things. So if you want to ask anything, just be involved also in any of this. I'm happy to kind of like mentor and coach you through some of this if I can help. So definitely reach out and say hi, and let's connect. So beyond that, what is the future of open source security? And so it's probably a lot of things. Supply chain security has been a big thing. Open source dependencies has been one. Security vulnerabilities, malicious packages, a ton of them. So let's go through some of these, and we'll try to kind of revisit and understand why the attack surface for Node.js and JavaScript application is actually big. Well, one of the things that we've seen recently happening is essentially typo squatting attacks, right? This has been happening for a few years. This has been happening across other ecosystems as well. It's not only JavaScript either. It's Python, like PyPI and Ruby Gems and others. So if you essentially install a package and it is maybe having a typo, the way that you wrote it or the way that you copy pasted from like a typo blog post or something, potentially if that namespace was empty and free to register before, then someone else could have registered it for you, and take the whole package as their own, and then publish something malicious for them. And with npm, when you install things, they can run arbitrary commands. So that's been one kind of attack that we should be very wary of. Others is just general malicious packages that we've seen on the ecosystem. So hopefully people do not do this too often. They do for some research purposes, but for other also malicious requirements as well. But we have the npm ecosystem that tries to kind of like guard all of this with a registry, etc. Still, the other case that we've seen that's related to supply chain security is that of compromised maintainers. So essentially, every package on this list at one point in time has been found to be, I would say, not vulnerable from a security vulnerabilities perspective, but vulnerable to someone basically be able to do an account takeover. So a person was able to get access to published versions of EventStream, of Express, of React, of MailCourser. For some of them, it's malicious. For other cases, it was more of like a person who we trust, and they have done some kind of case studies on weak npm credentials and proposed all of this back to the ecosystem. So we fixed it. But this still happens. And all of those cases are supply chain security that shows us why things are getting bigger. So what does it mean to get bigger? Is it or the problem space, getting bigger in terms of more things to worry about? Sort of. I think as developers, we are going to have our responsibilities space kind of growing, right? At one point in time, we're part of doing applications, and then we're doing Docker files and containers, and then performance, then security, then a bunch of stuff. So the more kind of we push to the cloud, the more responsibility goes over to developers to basically be able to own those resources and assets in the cloud. So today we're going to hack a Node.js application and learn how we do it. Essentially, we're going to start with an open source package, which is called Marked. We're going to be able to try and see what kind of vulnerabilities it have, and how do those vulnerabilities actually impact the application itself. The other case is going to be container, because we're probably going to containerize one of these Node.js applications that we have. And one of the things we would want to do is run it in the cloud in a containerized fashion. But containers do bring with themselves, more, some they are a good thing, but they do bring with themselves some kind of like things to worry about. How do we optimize? How do we make things secure? So we'll learn what are the attack surface there, and how does that again directly impact the application. And we'll finish up with an interesting, I think, a nice demo of the Node runtime. So what happens when Node.js as a runtime itself is having vulnerabilities? As that's kind of something that happens, and we'll drill through it. Well, before that, I kind of like want to take a second and recognize all of you like for joining us, because essentially it means you care about security, open source, and security, and software security, and being able to be here, learn, adopt some of these best practices is something I hope that you do, because essentially application security is hard, right? It's no one usually teaches that at like computer science schools. That's usually not mandatory thing to pass. It's not a requirement, and we learn it kind of like on the way, on the go, with each of our own passions and whatever we kind of like to do in software development. But the space itself is not as easy to deep dive into. So let me show you an example of why I mean why this isn't such an easy thing to dive into. Here's a function signature of an Express application. It's a very simple function middleware that has text, a request, a response, and it looks like it's running a function call inside it. That looks like it's running the database query or something like that. It has username and password and does something. Well, obviously there are some issues with just passing this username password as is, but even still, like you might think of maybe sanitizing it, maybe an SQL injection, but this isn't an SQL query. This is a NoSQL database like MongoDB and stuff like that. And so most of the Express application that you'll see in the ecosystem, they have this kind of body parser middleware for Express, which essentially allows you to take stuff from the body of an HTTP request and will parse it as a JSON string, as a JSON object that is very fast class citizen to the actual language runtime. So in Node.js, when you do request that body, that password, essentially that was sourced from an HTTP request where username and password were part of a JSON object that was passed to them. And as you can see here, it's already part of your requested body object. So it transitions from or gets serialized from just from a string on the HTTP connection to an actual object. The thing is, if I am able to then now specify the structure of objects, like specifically providing them things like dollar greater than something, that actually now is the value of requested body that password. So in essence, what it means is this user that find function will try to query the database and find a password with this kind of value which matches an object, which might not seem like it's an issue, but for MongoDB, when it sees those kind of objects, it understands them as specific literals that have modifiers and operators. Like it actually is going to find, it's not going to match a specific object. Instead, it's going to tell MongoDB to find any records that have or documents that have password with a value of everything that's bigger than essentially an empty string, which is probably every password you have there, especially if the username is going to be admin. So this is why this is bad. Now, it looks pretty, I guess, simple and innocent, and we know to sanitize, string and escape them and do all of those kind of things, do schema validation, whatever you want, it all works. So you'd expect this wouldn't happen to some projects, but here is Rocket Chat. It's an open source project that's part of a big company. It's a big commercial thing as well. It's open source. It's some chatting ecosystem, and you can see it's being used by a lot of users. And well, at one point in time, not so long ago, this is I think just 2021 or so, it was found that they have a NoSQL injection of the same kind of signature that we've seen right now. There's a users.find1 here that actually takes in this information from the params, the parameters, the URL parameters, essentially params.token, and just feeds it directly into this find one. This actually gets aggravated in terms of the severity, because this is even an unauthenticated endpoint, URL endpoint that you could actually access. As you can see, it's like get password policies for someone who needs to like reset their password and forgot password flow and all of those things. So it does make it into a very severe issue, which was found not long ago for a very, very big project. So those things happen. They happen all the time. And whether we code them or we use a lot of open source projects in our code bases, there's like a lot of vulnerabilities that we should really be aware of. And if we're using Rocket Chat or something else, we should probably be able to at least remediate fast when these things happen. I probably don't need to tell all of you about npm install, because when you do it, there's like a lot of vulnerabilities, fatigue, right? You install it, there's like a lot of packages, a lot of vulnerabilities. what do I do about them, right? Like how do we get from here to like a really better state? So if we think about some of those cases, yeah, some of these vulnerabilities could be stuff that we'll find in open source vulnerabilities in our dev dependencies, right? Like maybe it's not the exact thing that we should be prioritizing because of it's a dev dependency. But we should really have that context of like, hey, here's the real, for example, code injection in a template language, which we should know, for example, if it has a known exploit or not. We should know if it's fixed or not, which version it is. We should have all of that information kind of like quantitative, having quantifiable numbers around it, so we can actually prioritize them versus others. Like that's one way of looking at open source security as we dive deeper. But when we're thinking about our code, we start off with things like marked, right? Like this is, I do, const marked and then use it in some view in my Express app. So that's kind of like looks like it's my code, but essentially to build the application, I need a lot of open source dependencies, right? I'm bringing in a lot of NPM packages, and you all know that NPM packages kind of like get created more and more. I think we're probably around the 2 million mark for NPM packages around this point in time. Perhaps what you may not know too much is that the fact is also vulnerabilities that we discover in open source packages grow as well. And that's probably true across the whole board. And the more we kind of like put emphasis in terms of security research, we'll probably uncover more and more. So this is a thing that we need to understand, and understand the security risk. Other cases of open source supply chain security have been some that we have, not just security vulnerabilities, but some that are like from malicious intent. I won't go too much into event stream, but it's an interesting case to I think it's probably one of the most advanced and severe cases that we've seen, just because of the way that it was actually employed as an attack on the ecosystem. The time that it took us to find it as a community for like about 3 months, which is so long. So I highly recommend like looking into this and how someone was able to find himself gaining access to a module that has been downloaded for like millions of times a week. So yeah, event stream, you may not know of it because it's probably not your direct dependency, but it is somewhere that's been dependent upon by other projects like Webpack and others. So it's something that's super important to realize, and also I think study about. So that's one case, and it kind of like gets to a point where maybe we want to talk about when we choose open source dependencies, do we want to do some due diligence? For example, when I choose, I don't know, like a validation of dates or something library, I may go to Moment. But Moment, is it like mature enough? Is it still maintained? Sure, it's been downloaded like tens of millions of times the past week or month. But that could be like old legacy stuff. So I should really understand like what is going on with this package. What's the score for it? And so here is one example is you could use the Sneak Advisor to do some of those things, whether through looking them up via npm or Python, or even if it's a Docker image, you could just look it up. I think one of the other things that it kind of like brings up is where do we find vulnerabilities? So it's an interesting take in terms of where they actually found on the module tree. And so once, one of those things that we found out when we looked into this is NPM, as an example, has most of the vulnerabilities that when we do a scan with Sneak for users, we find those as like indirect packages. And it says something about, the whole module tree that's like very big. It's like very nested. There are like a lot of, nested modules with maintainers counting on, other maintainers and so on. Also, sometimes this means it's going to be a bit harder to remediate because you'll need the entire kind of like a nested dependency chain to upgrade everyone together and not pin dependencies and things like that. Well, that's one. But let's start off with a simple example. So let's imagine we're building this Node.js front-end app, which has like a simple input box. It's basically a to-do app. You can bring data. You can say I can style it as Markdown, and essentially maybe the first thing I'm thinking of is maybe I can go ahead and inject like a JavaScript XSS kind of things into it. So if I had tried to do something like this, here is how Marked supports sanitization to kind of sanitize the whole thing. So first off, there's going to be a link, right? There's going to be a link that it needs to support. So there's a function which gets the href. And as you kind of like browse through the whole screen here, you'll see that there is an index of call. So if I zoom in specifically inside it, you can see that this piece of code actually tries and finds everything that starts off with JavaScript colon or VBScript colon, and it like returns nothing, right? Like tries to sanitize and push this whole data away, which is great. It helps like sanitize the whole bad stuff that's coming up. But also at the same time, it does something else. If you look a bit up, you'll see the decode URI component. And if I zoom in on that one, you'll see that it unescape hrefs. That's essentially another mitigation. It's like another security control, which helps when the attack vector actually moves from just a VBScript colon to potentially trying to do HTML encoding of some of that information. Like I can replace the colon with, with an HTML entity that means to the browser, this should be a colon. So if I had done that, then JavaScript colon here that we've seen before wouldn't have worked. But there's the code URI component, which takes unescape href, which is another function, which if I zoom into again, now we can see there's like a regular expression, right? This regular expression actually matches those of HTML entities of a specific kind. And when it sees those HTML entities, it kind of tries to strip them away again because it doesn't want anyone to try and escape it. So it looks like a very, very thoughtful way of mitigating and sanitizing, but we'll see that it might have a problem. So let's go back for a second to like what would we want to happen, right? Like we want to have our Snyk application having like your application having some kind of like integration with a Snyk app where it can actually say, hey, you know what, I found a vulnerability, or I just need to upgrade a dependency from one to the other. And it gives you all this information, tells you like if it's like a recommended way to if it's recommended to really review it, or like it's safe because maybe there's like 1,000 other people who already merged it and it's fine, didn't break the build. This is all fine. But your Node.js app attack surface just got bigger. So what exactly does that actually mean? Like we talked so far just about dependencies. Well, imagine you have this package. Sorry, imagine you have this package JSON file, right? Like you import the repository into Snyk, and you have this package JSON manifest, and we detect all the vulnerabilities that you can see on the right. And well, you manage to go ahead and have a really good baseline where you have now scanned them. If you introduce new vulnerabilities, we'll also like find and hopefully you'll fix them very quickly with the pull request, just merge it. But is it the whole thing? So not exactly, right? Like what's missing here, and kind of like this is where I'm going with the whole session about like the attack surface getting bigger, is you're basically building an application not just to have it on source control and not just to have a package manifest. You probably want to deploy it somewhere, right? Like that is kind of like what's essentially missing here. Maybe it's like a front end app where you deploy it to Netlify over Cell. Maybe you containerize it. Maybe it's just a serverless function that you deploy in like Lambda. It depends what you want to do with it, but essentially you kind of like want to do something with this app. And so that is kind of like the missing part. Probably there's like good case that in your repository, you're going to have a package manifest file for your package JSON, your Python requirements.txt or whatever. And you're probably going to have this kind of like Dockerfile, Docker Compose, or whatever kind of like Terraform, whatever way of saying, this is how I want to build the image for the app. This is how I want to deploy it and orchestrate it and all of those things. And that is essentially where the attack surface really grows, because now the app is not just your dependencies, it's also your operating system and operating system dependencies and whatever vulnerabilities that actually includes. So before we maybe drill into this, I actually want to go back and show you kind of like, let's do a live hands-on hacking to some of these attack vectors, and let's start with a goof app. So we want to take that break now and do it, so we get some if there's like anything on the chat or anything else, we can go through them. So I'm going to fire up the app here. Okay. Mongo tree, just Mongo. And let's make sure we have the app running. There you go. Okay, cool. So now basically what we have here is our application, which we can do some things with. And so what I want to do essentially here is, well, let's say that I want to say, hi, Netherlands. Right, this works. This is fine. And let me fire up the app. this code. And there we go. So we have the app running as well. You can see I have marked, sourced it in. And as I was even typing and loading this, like I already got told by the VS Code extension from Snake, there's like a bunch of vulnerabilities and even like code security issues that I have, which is pretty cool, but we're gonna focus for now just on the dependencies themselves. And if I go and check like more cases of marked being used, I can see it even sanitized through option turned on. So I can go ahead and essentially now try and maybe inject some stuff. So let's see. Working. Let's see something that helps. If you want to chime in with ideas of what we can do, just go ahead and do that. How about we try this example, right? It goes there. And if we do something like this, okay, so this doesn't work, and we've seen why. Essentially, we've seen the source code of why this happens. So if I went and just really try to trick marked and say, hey, you know what? I'll tell you that you don't have a colon here in this way, but I'll actually replace it with something like this, which is the HTML entity for it, and maybe for the one HTML entity for the closing round bracket. If I do both of those things, like let's see what happens. Essentially, marked will try to, yeah. So marked has, and again, like what we've seen the code base in the examples before, where I showed this, it actually unescapes. It has this unescape function which detects that this is like there's a regular expression, finds all of those cases, and escapes them. The cases where this doesn't happen is where you might have something like a valid JavaScript keyword, like the word document. So if you do that, or maybe you have like just the word this, and this becomes a valid link, which if I click on, then becomes an alert, which is an XSS, which we don't want happening. And you kind of like want to know about those things, right? So if I go back to the Sneak app, see I have my Goof application here somewhere. So first off, we can see it has the, can zoom in a bit more, package.json one, which is for now what you want to take a look at. If I go back just again, see it was tested maybe 2 months ago. I can test it on a weekly, daily, on a weekly basis, on a daily basis, whatever I want. This is for my demo, so it's essentially I can either retest it now or not, which is I'm fine not doing that. And also I can say where am I getting this from. So maybe this is an integration from GitHub. Maybe this is an integration that I'm getting from the CLI and so on. Well, essentially, what I want to show you here is there's like a bunch of dependencies that I'm using, and I can go and filter through them and understand what's going on with the copyrights, the paths, all of those things. Looking at it as a tree, though, is a bit nicer because it gives me this kind of like this visualization that shows me exactly where vulnerabilities go in the app, like how is that actually composed, and I can drill down and see if there's like nested dependencies with like more issues. If I can go ahead and see fixes just for like if I want to be able to go and, for example, just by upgrading ST from this version to the major one, I'll be closing out a few vulnerabilities here, which is pretty cool. But if I go back into marked, you see that there's like a bunch of vulnerabilities, right? Like this and this one, and there's more. There's like cross-site scripting, regular expression out of service, all of them that actually pertain to this. And let's see which one is. It's like the regular expression. I think maybe this is the one. Yeah, so you see, if you actually expand the details, you can see all of those, like, how do I fix it and all of those things, but also like more information that we can gather from like GitHub or wherever this was posted in terms of what's the POC, how do we do it. There's like a learn section of like learning more about this, an interactive one. But if I go into the vulnerability, the vulnerability page itself, I like that we're curating a lot of this information. Like you could go to the GitHub PR and get more information in terms of, well, when was it, kind of like suggested, what's going on, did it get fixed, did it not get fixed? Apparently this was like a pull request with some fixes, and even the tests were updated. So if the maintainer had like merged this and then they did a breaking change that broke this, and you have regression tests here, which is pretty cool. One thing to kind of like just understand or keep in mind is this thing was opened back in May 2015. And even though people were like, very thumbs up in terms of, this is something we should fix, it really took a bunch of time for the repository maintainer and essentially kind of like the community to just get around it and fix it. About a year. So this was out about a year, and you could have been kind of like weaponized with this if you hadn't fixed that in production or like moved to a different library or something else. Like this is super important. But let's go back now to the containers. So like we've shown like a bunch of if I go back over here, so we've shown like this is my app, and I've got like a bunch of like dependencies. They're vulnerable, and like we see how it's vulnerable. Well, if I go back into the fact that I actually have a Dockerfile here, right, which is back to where we left off here. So we have a container. Now we've basically want to take this up and containerize it. So if we do that, a couple of things about containerization. Well, it's a really good way of kind of like doing deterministic builds, cross lightweight cross virtualization kind of application bundling and so on. And won't go into like the whole merits or perils of Docker, but essentially, even with this kind of Dockerfile, which is what you see right now, there are a lot of instructions here that are not exactly optimal and not really production grade or best practices. First off is like that from node. So a Dockerfile is essentially just this text file that says how do we build the the basic image that holds this container up in the air when it's run, when it's spun up. So if you just do from node, essentially it means it takes the latest version, so we don't control it. But also it's maybe a very big image. So besides the size that you'll have to like pull all the time, like maybe gigabytes of data, it also means essentially it also has more dependencies, more open operating system, open source dependencies, like curl and git and whatever, all of those kind of SSH, libSSH, GCC, whatever. Do you need them? Do you don't need them? Because they may have vulnerabilities, and if they have vulnerabilities, that may impact you. There's like a bunch of stuff there. And we've went back a couple of years ago and scanned kind of like these top 10 Docker Hub images. And as you can see, like some of them had this, well, I mean, almost all of them, except like in 2019, one Ubuntu had 0, but all of the others, and Node kind of like on the top there, had hundreds of vulnerabilities just on like the base Node latest image. So the starting point isn't like really optimal, right? Like we could do better. And like, let's see, why does that actually relate back to like the app that we're building and the whole attack surface? Well, if I'm actually taking an image and then I'm continuing, and like maybe I need to install something, because let's say that this is an app that actually goes and takes an image, and maybe it needs to convert the image, like it does some manipulation on the image itself, like resize it or whatever. I might need ImageMagick, which is a very kind of like popular and kind of like very veteran Unix, Linux kind of dependency. It's a library and a tool and just some SDK, etc. But if I'm just going to go ahead and install it, which is pretty easy to put it on the container image, do I actually know all the potential vulnerabilities that it's bringing? And like, does that impact the app? Is that like even relevant to what I'm doing, etc.? So a lot of questions that we should ask. But even more problems here is, if you do npm install, then what are you actually bringing in? That's like not going to be a deterministic installation for every Docker image that you'll build, because it doesn't respect the log file and it might like mutate it. So this is like also like not a way of doing that. So it's like a bunch of things that's going on and are problematic here. But even specifically, if you go back to the app, remember we said before, like one of the stuff that we want to do with kind of like hacking here is the runtime itself. Like Node.js as a runtime may have some specific issues in terms of like security vulnerabilities that are detected upon it. Like it gets compiled with like link to the libeSSL. So maybe that's an issue. Maybe something in libuv. Maybe something in the whole space. Maybe something in the space of the node domain and some like core modules. All of those kind of like impact the application itself. I'm not entirely sure how much developers pay attention to all of these runtime versions that Node has, and know that they're using a secure or like a patched and updated version, rather than just maybe pulling a new Node runtime because they want to use like ESM and like the new features and whatnot. So I want to hack the application. I kind of like wanted to do the exploit first with like the open source library first, Mark, like just get things off the ground and make sure that like we're all kind of on top of it, and it's not just slide. But we've done that, right? We've done this open source library. So what we're going to do next is go ahead and work on the containerization space, like how the attack surface has actually got a bit bigger. And while we're there, we'll actually show you why the Node runtime could be a risk, because it's like directly someone can interact with it. So let's do this and understand a bit more of like what's going on. So if I go now into, where is the terminal? So I'll quit this app, which was the Node one. Okay, and this is MongoDB. I want to go into this other app, which I did build it before. You run this. So let's see. So I'm going to basically build this. I'll make it a bit bigger. Build this new Node.js application and exploit it in 3.1.1.2. Let's see how that works. I think it's running. Okay, 3.1.1.2. It's listening, and we can close this VS Code extension, the VS Code window. Okay, there we go. So once we do this here, now you kind of like think like what's going on. Essentially, this is an app that allows us to browse the image. It allows us to, sorry, it allows us to browse for a file, so we can upload an image and resize it. So I can do things like, where is my server.js and my Dockerfile? Let me remove this here. Okay, so this is the Dockerfile. It's pretty simple, just from Node. We went back in time to Node 6.1 Wheezy. I'll make this a bit bigger. It's a very simple thing. But then also on the left side, my whole Node application here that I've containerized is pretty simple. It's essentially having an Express app, just like I can interact with it on this kind of like website. So just having it exposed over HTTP, and then I have an upload route and a public route, which is serving my my static HTML here to just upload an image. But essentially, you can imagine this takes something from like SQS or some other message queue that you want to work with, take images, and this post endpoint have this Twitter picture, which I can go ahead, run this child process exec file API, and then convert the image from one to another. So if I am actually doing that and I'm converting the image from one to another, I can actually resize it and maybe even like want to convert like PNG to JPEGs or something else. So I can do all of those things just with the fact that I have ImageMagick. And look, I just haven't even installed, like I didn't have a run apt-get installed or something for ImageMagick. I just Googled some things and I've seen that it's actually available and I can actually run this command. So let's see how this works. Before that, I actually want to show you one other thing. We have some things around here, and that is, let's see. So the app is running, right? That's kind of like what we ran, this container. And let's connect to it. So essentially, you can see this is, the application that's running just on my machine, but it could have just, been running on the cloud. Doesn't really matter. I'm in it, and I can look. It has this server.js. I can cut it inside. So I'm on a show, and I'm showing you that it's essentially the same thing that I showed you in code is running right now, right? So let's keep this up for here, and let's upload a picture. What could go wrong, right? If I upload the Yoda picture here, let's see. Well, it's not really running a Yoda picture here, but it's a different one. But if we go back into the app and I just list all these files again, you'll notice that, well, there's like a new file here of, maybe someone was hacking through this and left a message and, kind of like maybe did some malware, some malicious thing. So like, this is pretty bad if someone is able to just create files on the on like the container just by uploading a picture. But why is this actually happening? So let's take a look into this. So I want to see where all these exploits are. So let's see what this image is about. So first of all, it's not just a regular, like you'd expect, like a binary image. It is actually using a feature from ImageMagick that's called delegate. And what it does is it allows you to specify and delegate specific functional image drawing capabilities or functionalities, and to to some other kind of features that exist within ImageMagick. So I can define the the viewport and everything else. And if this is what draws the actual graphic here, all this pie chart. But if I go down to all of this, you can see it actually has this command that says, fill the image data with this URL, which doesn't actually exist, which I don't really care that it exists or doesn't, because I pipe all of that output into a command. So in this case, like, it's something that creates empty files. In this exploit that I have in this version is called RCE0. In the one that I had on the exploit on my desktop, it's something that was called something else. And so that is what actually created this file here, which did not exist before. So essentially, just by uploading a file to an image file, which I control, into this container, I was able to go ahead and execute any commands I wanted on this container. So I could go ahead and do anything like creating a remote traverse shell, reading your .env files, reading your the source code of your applications, whatever I want, and send it over. All of those kind of things, if you do them, if they exist as like sensitive stuff on the container, which sometimes they do, like configuration keys and stuff like that, I could actually run any command in the container and essentially just compromise it. Now, here is another. So I just went down to like my projects here and just opened the Dockerfile for like when I tested it, a while back, and you could see it's it's also a version of Node 6. It's a slightly different image, but it has still 1,000 of vulnerabilities in it, and there's like severity critical is like 55. And the hard things about mitigating Docker images related or container images related vulnerabilities is that there's like a lot of them, right? Like if I just filter this to ImageMagick, there's going to be a ton of them, like 250. And going through each one of them and just doing, null pointer the reference and whatever, that's like really, really hard. And I'll show later in the slides, like, why is this happening with ImageMagick? Because it's like a very popular vulnerability. But essentially what you'd want to do is, whether you do like a Docker scan or something, which is like a sneak integration to find those vulnerabilities, or whether you kind of like use the app like I'm using here, it shows you your current image, but also Sneak gives you those recommendations. So like this is like data-based decisions that you can make on how to have like a healthier and more secure container image. So the easiest kind of like a lift would be from Node 6 to Node 12 probably, and it already like kind of like cuts by half all of those vulnerabilities that you have. So like that's still a lot, but like a lot less to go through and triage and figure out like what's the risk that you currently have. But also you could just have like maybe alternative upgrades, which is maybe if you can move to like Node 12 Bullseye Slim, which is like a very slimmer image. So it has less vulnerabilities because it has less of a software footprint. Like it's like less dependencies in it. So you could move to any of those, whichever makes sense to you and your application, and already have a better starting point, and decide whether you should ignore some of them because you're not using, and everything else that you normally do when you want to like triage vulnerabilities. I could open a fixed PR, which essentially will just open my GitHub here and open a pull request that updates the from of the Dockerfile from Node 6 stretch to something else like this or something else. Or this will happen automatically if I just connect it, enable it, and this is the whole automation stuff that Sneak does. So let's say we went ahead and we have now gone back in time and we've changed from Node to something else. Let's say at this point in time it was Node 850, which is the long-term support version. So if we do that, I need to like build a container. And what happens if I do that? Go out of here. Go over build. We'll go ahead and rebuild this. Have 850. So all good. Let's run it. Maybe I want to try something like curling this sort of address. Like what's actually going on here? Let's take a look at this for a second and kind of like try to. Let me push this in again. There you go. Now it's bigger. So what's actually happening here is I'm making a simple GET request to the container that's now running, as we said. And %2e is an encoding for the URL that specifies a dot. So this is like dot dot slash dot dot slash. So it's like a very simple example. It's like the classic use case of path traversal vulnerabilities, which allows you to like traverse the tree and access some specific files. And you can see it follows a very special pattern where you have to like put in a directory name that doesn't even exist. For example, like this doesn't need to exist, but you kind of need to do that to create a mask and then kind of like traverse all of this back. And then I have user src goofs like server.js, which is the code that we have on the server. So if I run this, what you see here is now this is serving any files on the container to me. So any GET request doing that from the browser or the CLI will basically be able to give me any file that exists on the server, or most files, depending what is supported. I can go ahead and take this. I can go ahead and take password for like the fun stuff. I can go ahead and take your Node, module JSON and whatever package JSON, package log file, see all your dependencies, and continue from that point on, and then traverse. Like it starts from a from a path traversal vulnerability, but the impact is like potentially really, really big, and that is like why the attack surface is up. So this is happening simply because I'm using Node 850. Like nothing else is enabling this path traversal, not my code, not Express, not this exec file, not the dependencies inside this image, but the fact that Node 850 has a runtime vulnerability, which if we look at, trying to get there. Oh, nice. No idea. Let's go here. 850 security. Okay, so just by a quick search here, change to English, yes. So I have a path validation vulnerability dated back to 2017, which isn't a ton of time ago. Like I'm pretty sure some systems still run Node 8. But you can see there's like a core module in Node.js that's running. It's if the path module is being used. It has a validation vulnerability which allows for path traversal and things like that. So essentially, someone is able to access files on my system, and this is just because I'm running a vulnerable version of Node. That's kind of all the demos, but let's go and like go through them, right? Like hopefully that was like fun, giving you some stuff, but what can you do about it? So some of the stuff we talked about them before. And so remember image magic as like a vulnerability that I showed you. That is actually dubbed as a vulnerability called image tragic, which was a really, really big thing a few years back. And you can see it's called improper input validation. It doesn't have like a very gigantic name of like remote code execution vulnerability, red flags jumping on you. So finding this and knowing that this specific vulnerability is important out of like the 250 is like super hard, and that's like why you kind of like always want to upgrade and like diminish the attack surface and the risk that you have. But also if you have those vulnerability insights, like more things, that context that help you understand like where vulnerability is coming from. So for example, maybe in your containers you had actually done an upgrade install to image magic, so we can tell you where this vulnerability is coming from. Is it in your base image? Is it in your specific Dockerfile instruction like a run command? Is it somewhere else? Also, at the same time, you're having a lot of vulnerabilities like this one has for Node 10, 862 of them. And in Node.js, there's like, if you look at the tags, this is a bit dated, like maybe a half a year ago. So it has like almost 4,000 image tags. Like which image should I go to node 10.4.1, 10.15, node 12, whatever. Like you're maybe not really sure which your app is compatible with, and which is actually fixing rather than introducing more issues. So that is kind of like where I was showing that issue before, where it gives you actionable recommendations, so you can like mitigate based on specific data points, right? Like you could just move from your current image of Node 10 to this Node 10 Buster Slim, which has like 54 vulnerabilities footprint versus 862, which is like considerably, to all opinions, a better state. So kind of like transitioning from the fact that like there's your code, right? Like we're talking about the attack surface. So we talked about like there's your code which has issues, but it also, your app actually uses a lot of open source dependencies, like the attack surface expand. And like this is, I think a normal mindset for developers today. Like they use open source dependencies, they understand, the risk and the ability to like, they need to mitigate fast if something's happening. But also now we kind of like get the purview of there's more than just even the dependencies in the app, just like how the app is containerized, where is it deployed, all of those kind of things. It's like a serverless Lambda things, and if so, what's going on there, how is that running, and so on. But there's more, right, at this point, which is I feel it's very fitting to be at the Cloud Pirates kind of like a CNCF space here and talk about like the Kubernetes space, because that's kind of like what's next. That's like the app is also not just running in the repository, not there for like the repository, not there just for running somewhere. If it gets containerized or some sort, it actually needs to be orchestrated in the cloud, right? Like it needs to go up and down. It needs access to resources, configurations, and things like that. So there's like a lot of places where we can have misconfiguration issues when we define what is the state that we want to have, or essentially kind of like determine how the app is supposed to run. So if you're doing anything like Docker Compose app or Kube control apply or Firebase deploy or Netlify deploy, all of those things kind of mean that you're essentially a cloud native developer. And because you're building for the cloud, you're using a lot of like cloud related aspects and resources, that all of your apps are probably driven by configuration and infrastructure as code, right? So all of those like Firebase, all of those things kind of like apply to you. And this is where the attack surface, further goes on. So we won't touch about all of those, and like we want to like a further out deep dive into like infrastructure as code issues, but it is an important one. It is have been deemed by like the NSA as like the #1 cloud vulnerability, because of the impact that it can actually have on specific deployed applications. So some takeaways quickly before we kind of like sum it up. First of all, like you could just sneak or like use some other tools if you wanted through different ways. You could use npm audit, you could use GitHub dependabilities, are all great tools. Essentially, what I'm going to advocate for is whatever you use, get that integrated with your source code repositories in whatever way, like whatever tool you choose, because it gives you those other advantages where, first of all, it tracks all of your package manifests like across not just the language ecosystem, also like the Dockerfile and things like that. It can also like continuously scan them. It can continuously, provide you like automated pull requests and stuff like that. So like all of those things are like really important to get your security as like not being just like a one-off kind of like, I tested, it's okay, I clean it up and like that's fine. And more, not doing that, but other more into like the DevSecOps where you have like continuous security and things like this. If you're interested in some kind of like best practices from anything in terms of like how to build, secure boot, Spring Boot applications, to how to containerize your Node.js applications in Java and Python and some others, like a bunch of them on the blog. So just go to like the Snyk blog stuff and search for these things. And I think that might be kind of like the favorite, but not the least one. And that is kind of like the Snyk Learn resource. So this is like a really, really good way to just skill up in terms of code security issues. So anything if like you're seeing directory traversal for the first time, if you have no idea what is like prototype evolution, these are like really, really small kind of like bite-sized kind of like courses, interactive as well. You can like type things in and you can like learn about those issues and discover them through just like a web thing. It's totally free. You don't even need to like sign up or anything. So I really recommend this one. So that kind of like sums it up. Kind of like stay safe in your journey to cloud native, and hack responsibly, I guess. So that's kind of us. David, is there anything else that we've got on the chat, or
not, not that I see in the chat, but maybe we have a question from the audience. Let's see.
Live audience. I'll get my water.
Yeah.
It's a question, but it's a thing that it's bothering me recently because I did some, I switched companies, so I've done some reflections. So, and your graphs show that as well, like the numbers. So we continuously see more code. We continuously see more code, and we continue to see that
more CVs,
stubborn correlation between more code, more vulnerabilities. So are we actually on the right path with everything we do in application security? Because we don't see change in trend. So that might mean two different things. Might mean that we didn't have the visibility before, and now just because more people are looking at it, we find more vulnerabilities. But it definitely does not show a good signal that we're actually resolving the problem. So it's more about, approach-wise. That's one. And because, yes, this is just different technology that is currently modern, or it's currently popularly used, but it's, the direction is what is sort of concerning. So
Yeah.
what's your opinion on that? Like, do we actually have enough resources and solutions, may that be standards, processes, tooling, what have you, for developers to actually resolve this problem in the foreseeable future?
It's a good question. So, first off, security issues, vulnerabilities are kind of like security bugs, right? And like you'll see also like more bugs the more code you write. Like it gets complicated, like maybe even defects, because it's kind of like moves away from maybe from like the spec or the requirement. So I think it's natural to see some correlation, and I don't like this hard correlation, but like you'll always have security vulnerabilities, actually, just like you have like security bugs or like software bugs in general. But I also think like if you try and look at like 20 years ago, like what the web looked like, it even like 10 years ago, it wasn't very performant, right? Like people did not think about like the size of the JavaScript that they're sending out, like time to first render, all of those things were not like something on top of their mind. Like how did we fix it? So I think we can like fix it in like two ways. One was like the frameworks way, so like all of the frameworks, the tooling, kind of like understood that they need to like build like really performant web applications and web pages, and it was just like built in, it was like part of this. But the other thing was like a lot of education, like we were having a lot of like performance conferences and performance talks, and a lot of education of like why this is important and how do we enable it. Even there's like actually a very weird, I think, correlation where we have like the more that we have faster and more compute power in our like mobile devices, we're still talking more about still optimizing it and like giving you the fast stuff. Like it's not the other way around. It's not like we're sending bloat of JavaScript and stuff to the mobile devices and say, hey, deal with it. So I think there's some kind of like between those two, between the tooling and the education and awareness, these are like two things we still need to do a lot more in security, and the whole developer security space where we really empower developers to fix security issues, just like we empower developers, till today to, take ownership of like the bundles that they send out, like the front end or whatever. So I'm saying it, and I think in several ways. I think like the education awareness is like a very obvious things. But on the tooling side, like NPM audit, basically, having the NPM team having the decision.
I understand your point. Thanks for that. But let's take tooling as a next topic to discuss. With the ecosystems that we have, which are growing in both size, adoption, and vulnerabilities present in them, right? Have we done anything to address the issues not on the developer side, but on the ecosystem or the package manager side. You know, we have NPM audit, but why a developer should have an extra command to run? Why should he, she, what have you, have at all the option to install a vulnerable dependency? Right?
Yeah.
You get my point. So
yeah, but
still,
it's
why are we trying to solve everything at the developer currently? You know, that's the focus. Like let's try to fix it on the local machine. But even then, we still give a lot of room for mistakes to happen, right? And that is not supported by. I mean, those mistakes potentially can be addressed by some of the default tooling that the developers use, and not by adding more tools to it. You know, we have quite a lot of tools nowadays.
Yeah, definitely. So I think like the question of like why do we allow developers to like install vulnerable libraries? I like completely agree. Like that it would have been nice if there's like more interactive way of like telling you like before you install a package, like hey, there's like maybe it has vulnerabilities or something inside it, like be careful. But sometimes like most of the time you don't install you know, a vulnerable dependency. Most of the time it's like you have a dependency and then like 2 months later you find that it's vulnerable, so you have to fix it. So it's not like we can give them like a pristine package and it's like it's amazing and like this will be the code that forever works. So I mean,
it's not a vulnerability the developer introduced, so we cannot really
no, it's a vulnerability that they did not introduce, but they received because some other maintainer introduced like 2 years ago. Yeah, and I think the other case for it is an interesting one with the future, and that's kind of like where we're going. I think with kind of like augmented development, where in the IDE you may have things like either GitHub Copilot or like the Sneak VS Code extension, and like those two kind of like as you type, they either I don't know if GitHub Copilot like helps you to the not to avoid security issues as you type them, which would be great if it does. But like this is the future of things, right? Like that's helping you code, but also like code securely. Yeah. So I'm like a big supporter of both of those. I think this the VS Code environment, like being in the IDE, is like like I was showing over here. It's like the moment that you open your package JSON. This is like a different app. But the moment that you do some stuff here, the ability to just at the moment that you write code, give you that insight. That is the most. Yeah, I totally I love this, and I think like this is probably the future.
Cool.
Good questions.
Yeah, and the last topic is and you've also explained, and I think it's pretty obvious to maybe make a wrong conclusion that open source is a lot more insecure than we hoped for.
Yeah, I don't think there's like any study that I read that says that.
Yeah. Okay.
Not that I read. Like maybe there is, but I did not hear about anything like this.
It's wrong conclusion. If you look at the open source packages and the numbers, I can make that wrong conclusion, thinking that it might be more.
Well, I don't think. Yeah. Well, that doesn't compare or benchmarks closed source vendors.
So I was curious if you actually have that comparison made with closed source or with the latest trend.
I don't have it.
Source, which is
a
whole topic of discussion.
Yeah, I don't have it, but like, I don't know if it changes anything. Like, let's say that we find there's like some, I don't know, better security score for like closed source. Will everyone now just close it? I don't think that's like going to happen either. Like, even if it's like 10% lower, whatever, like you'll find. I don't think like, and it's not anything like probably more than that. That's like not going to change anything anyway. So.
No, it's just a whole area of discussion, but we can also do that.
Yeah, cool. Cool. Anything else from the chat, by the way?
Let me quickly check. No, nothing.
Anything else?
Not yet. Other attendee.
So skills application is a big topic, right? So and then, what do you think about software bill of materials? It's open source tools that manage, sign, and can attach software bill of materials to containers. Did you?
I don't. So SBOM isn't specifically about signing them and having like the provenance and everything. So I think it might be like we're connecting several things together, which might be good because maybe that's like where it's going. But I think like so I think SBOMs and like the inventory side of things is something that's like probably should be transparent to developers. Like if we're talking about the developers themselves, like I don't think they need to care or know that there's like this thing that's called SBOM or like there's like CycloneDX and like a different SPDX or whatever other formats. Like they don't care. I think that's more of like regulatory, kind of like something that the AppSec team does, the CISO team, the security team does, etc. And they provide it, and it's this thing. So from that sense, I don't think there's like a really strong correlation to developers. But when we think about developers in the hat of being like maintainers and like contributors, I think that whole other part of it of like ensuring that the code that you actually like did an npm install for wasn't wasn't altered and changed on the way by someone else, which can happen across the supply chain. Like it could be your package that was changed in npm.js. It could be your source code repository at GitHub. It could be the build on GitHub or something that was changed. Like a lot of stuff that could happen, and those I think we do need to track. And like those developers need to have some integration points. Hopefully, like we do it with good DX, so like it doesn't have a big overload to developers. Cool.
All right. Well, if we don't have any other question, then I want to give a big thank you and welcome to the Netherlands. Is your first time or?
It is my first time.
Okay.
Yes.
Welcome.
Thank you. It's a very beautiful and amazing place. I'm enjoying it.
Definitely. You got good weather today, so hopefully tomorrow and for the weekend as well.
Yeah.
And I just want to remind the audience that Liran will be tomorrow at JS Nation,
Yes.
right? And React Summit
on Friday.
On Friday, yeah. Okay, perfect. Well, I want to thank you, Alessandro, for hosting us at Cloud Pirates today.
Thank you for the space. It's amazing here.
Yeah.
If you're in the Netherlands, come to Cloud Pirates because it's a pretty cool space here.
Looking forward to host more meetups.
Definitely, we will definitely come back.
I can attest that the setup is pretty cool.
Yeah.
Liran will come back also. Yeah, definitely.
I really will.
Yeah. So I just want to say that thanks everybody, and again, if you have a space actually where you want to host your DevSecOn chapter at your company or at your co-working space, just reach out to me, to the DevSecOn community on our Discord channel, and I'll make sure that we'll make this happen. So thanks everybody, and I'll see you to the next meetup. Thanks, Liran.